Hi everyone, welcome to my YouTube channel. Java 22 brings a host of exciting new features designed to enhance developer productivity, performance, and security. Key highlights include the foreign function and memory API for seamless native code integration, and then pattern matching for switch to simplify complex data handling, string templates, and much more. Let's see each of them in detail with easy to understand example. Let's dive in. Let's create a simple hello world program in Java. Imagine you are a beginner with no knowledge of object-oriented programming concepts. When you see a program with terms like package, public class, and void main, and even string array with args, it will be really overwhelming. Writing your first program might seem daunting with all this syntax. To simplify things, Java introduced implicitly declared classes. Let's take a look at how these new implicit classes work. First, you might notice that this program has no class declaration. Oh, and even package declaration. You may wonder how Java can use object-oriented programming without a class declaration. This is a valid question. However, implicitly declared classes do not need an explicit class name. Instead, the class name is derived from the file name, and you don't need to declare the class explicitly. You can still declare your variables if needed. You might also see that our main method has no arguments. This is called an instance main method. Java handles all the background tasks, so as a new learner, you don't need to understand these concepts at the beginning of your learning journey. As of now, you can simply run this program and the main method will be invoked by printing hello world to the console. I believe this feature will significantly benefit new learners and instructors. Java 22 introduces a feature called unnamed variables, which can simplify your code and make it more readable in certain context. Let's try to understand this with a simple example. In this example, the variable underscore is used as an unnamed variable. However, if you try to use underscore further, it will result in a compilation error. You might wonder why we would declare a variable with underscore if we cannot use it. Let's explore scenarios where unnamed variables can be practically useful. In this example, we will try to create a number list with arrays 1, C, and 3. Now we will iterate this list and we will use integer parseInt, which is going to pass the string into an integer. In the catch class, we can catch the number format exception with the variable e. Next, we can include the print statement. This is not a number. If you notice this code, we are not using the variable e in this case. Therefore, we can replace the variable e with an underscore. This is a simple example with a try catch block. Let's move on to our next example. In this example, we will see how to use unnamed variables in the lambda expressions. Let's initialize a hash map with the key Arul and an empty list. In the next line, we will try to add a new key Raj with Java as the value. Since Arul is not a key in our map, we cannot add it before initializing the list. Here, the variable v is not used and is unnecessary because we are just initializing it with an empty list. We can replace the variable v with underscore, making our code more readable and indicating that the variable will not be used any further. Let's look at another example of an unused variable with a record. We will create a simple record named person with name of type string and age of type int. Next, we will create a list of person records with some sample values. We will then iterate over the list of person records and check their instances. In this if condition, we are also using pattern matching, which is another feature introduced in Java 22. We will discuss it in detail in the next section. But for now, just focus on this code where we are checking the instance of the person record. If it matches, we print the name. Notice that the age variable is unused. We can simply replace it with an underscore. Java 22 introduced significant improvements to pattern matching, a feature that has been evolving since Java 14. We will see how to use pattern matching and the benefits of using pattern matching. Let's look at a simple example of using pattern matching with a switch expression. We will create a method printObjectInfo that takes an object as an argument. In the switch expression, we will print the value based on its type. Notice that we are not explicitly using instance of for type checking. Instead, we directly use the type followed by a variable to print the value. Using pattern switching in switch expressions simplifies type checking and casting, making the code more concise and readable. Prior to Java 22, the call to the superclass constructor must be the first statement in a subclass constructor. If you try to place any statements before the supercall, the compiler will throw an error. In this example, prior to Java 22, we have to call our superclass constructor with argument modified with message. We cannot initialize the message argument before the constructor. But after Java 22, we can declare our variable before the super statement and we can use this variable in the super call as an argument. This feature enables more natural placement of logic in the constructor and improves the code readability. String templates in Java 22 offer a new way to embed expressions directly within strings. This feature allows developers to avoid cumbersome string concatenation and string.format methods, providing a more natural and intuitive way to construct strings. You might have seen this feature in other programming languages, but it's great to see it in Java as well. Let's look at a simple example. In this example, the string.format method is used with a format string and two arguments, name and age. The format string contains placeholder %s and %d, which are replaced by the values of name and age respectively. %s is a placeholder for a string and %d is a placeholder for an integer. This is the conventional way of formatting strings in Java. Now let's replace this with string templates. To use string templates, we utilize the str keyword from the java.lang package. We need to use str dot followed by our string, and within curly braces we can include our variables. This approach eliminates the need for concatenation or formatting methods, making the code more clear. Java 22 introduces stream gatherers, a new mechanism for manipulating streams of data. Stream gatherers allows developers to create custom intermediary operators that simplify complex operations. At first glance, stream gatherers seems a bit complex and obscure, and you might wonder why you need them. But when you are confronted with a situation that requires a certain kind of stream manipulation, gatherers become an obvious and welcome addition to the Stream API. In this example, we will try to explore two methods, Windows Fixed and Windows Sliding from Stream Gatherers. First, we will use Windows Fixed. The list contains integers and the stream method is called to create a stream from the list. Then we can use gatherer method, gatherers.windowsFixed of 3, which specifies that the stream should be divided into fixed sized window of 3 elements each. The toList method collects these windows into a list of lists. We can run this program and see the result. This approach is useful for processing data in chunks of a specific size, making it easier to handle and analyze the data in a structured manner. Next, we will see window sliding. This gatherer method is then used with gatherers.windowSliding of 3, which specifies that the stream should be divided into sliding windows of 3 elements each. This approach is useful for processing data in overlapping chunks, allowing for more granular analysis and handling of the data. Foreign function and memory API is one of the powerful features introduced in Java 22. This enables Java programs to interact with external code and data written in other programming languages. The Java virtual machine provides a secure and isolated environment, preventing unauthorized access and memory corruption. However, this isolation can limit interactions with system level resources for native libraries. Traditionally, Java uses the Java Native Interface (JNI) for such tasks, but JNI can be complex and risky, potentially leading to memory leaks and crashes. The foreign function and memory API offers a safer and more straightforward method for calling a native libraries without sacrificing the JVM security and stability. This opens new possibilities for Java application to leverage the performance and capabilities of native libraries. Now with an example, let's see how to call a C function from our Java code. The following code demonstrates calling the string length function in C to determine the length of a Java string. First, we will create a symbol lookup object to find native symbols on the C library path. Next, we will create a method handle object for the string length function. And we can use standard library.find string length. which will load the string length function from the C library. This object contains all the information needed to call the native function, such as the function pointer and the function signature. Then we will create an arena object, which is a region of memory used to allocate half heap memory. The try with resources statement ensures that the arena object is automatically closed when the code block exists. Within the try block, the code allocates a region of off-heap memory to store the string Java22 is great. Memory segment object represents the allocated off-heap memory. Next, we can use our method handle string length to invoke the string length function from the C program, passing the memory of the string Java22 is great as the argument. Executing this program prints the length of the string calculated by a C function using the foreign function and memory API. As you can see, the foreign function and memory API is a powerful tool that can be used to write Java programs that interact with code and data outside the Java runtime. It is a safe, efficient, and easy to use alternative to JNI. Some situations where you might want to use this APIs are like to access a machine learning library that is written in C or C++, or to interact with a hardware device that is controlled by a native driver, or to implement a high performance algorithm that is written in C or C++. Thank you for watching. If you enjoyed this video, please give it a thumbs up and a subscribe to our channel for more similar content. Don't forget to hit the bell icon to get notified whenever we post a new video. See you next time.